Hello viewers, I am Raj and welcome back to my YouTube channel. First of all, I would be thanking every one of you for your love and support. The channel is growing slowly and I have so many things planned for this channel. So stay tuned, and if you haven't subscribed the channel, please subscribe it. So let's start today's video. So hello viewers, today in this episode of Competitor Programming with Python series, we will solve this Leetcode problem. So which is removing nth node from the list, of the end of the list. So this problem seems very silly and simple when we view it for the first time, but it is far more complex than we thought of. So here we'll be provided with a list, the head of the list, and a value n. So n is as it is written, n will be always valid. So n won't be the value which is like the greater than the total number of nodes exist in the list. So we have to remove the nth last node from the list. So let's understand more into this problem. So what this problem is. So we'll be, let's say we have this list given over here. So 6, 10, 15, 7 and 2, and we want to remove the third node from the end. So which is ideally we want to remove the 15th the element or the node with the value 15. So how we can, so the output we want at the end of the program which is like the 15th node removed, and the 6 and 10 are joined to the last two elements. So this is the output that we want. So but since we are talking about linked list, so we have to be careful whenever we are doing any kind of operations with linked list, because in linked list we are actually trying to work with the memory pointers which can be spread out all around the memory. So we have to be careful whenever we try to delete or we try to break a link. So essentially we want to do this. So we want to break the link which is between 10 and 15, and I want to make a link between 10 and 7. So here the second link is optional. Like if we don't break it, it's also fine, but in order to free the memory, we have to break this link as well. So we have to essentially delete the node 15, and we want to establish a link between the 10 and 7. So in the data structure that we have been provided is something like this. So which is we have the data part, and then we, in the second half or the later half of the node, we have the link to the next node part. So this is nothing but this arrow which is made over here. So I have the link to the next node which is in line in the linked list. So in terms of solution of this problem, we have two kinds of solution that is possible, at least for me as well. So first of all is the two-pass solution. So two-pass solution is also order of n solution, but it has two iterations of, or two traversals of the list. So in the first iteration or the first traversal, I will just go through the whole list and I will count the number of nodes that are present in the list, and then I will perform t equals to t minus n. So which is basically nothing but I am calculating the node which I want to delete using the n provided by the user, and the second pass I will reach the nth node and then I will delete it. So essentially these are the two pass solution. So but okay, this is fine, like this is also order of n, but how can we improve this code? Let's say I just want to do it in one pass. So or in order to do it in one pass, I will propose a solution in the next slide. So by the way, both of the codes are of order of n complexity. So any one of is fine, but we want the accuracy more. So then we have to use the order like the one pass solution. So what the solution of one pass is, we will have the first, we'll have the two pointers like pointing at the first node of the list, and then in each iteration I will be incrementing one of the pointers again and again until and I will count that how many nodes that it has already encountered. So as soon as I get a window of n nodes, I will start incrementing the second pointer as well. So like I'm incrementing one pointer and I'm waiting for it to reach the value of n, like n nodes has been passed. Then I will take a sliding window of a kind of a thing. So I will just move the sliding window, and as soon as the first pointer reaches the end of the list, I will be at the nth last of the I will be at the nth last node at the list of the list. So that's how it is done. So let's say in this case I have three I want to delete the last third element. So I will start one of the pointers from 6, then as soon as the node reaches the 15, I will start incrementing the second pointer. So as like in each iteration, both the pointers will increment one by one, and whenever the first node, first link or the first pointer reaches at the end of the list, my second pointer will be at the nth last element. So practically that's how it is done. So as soon as we reach the nth last node, we can simply delete it. So deletion, how to delete a node from the list, that I will show in the code. So let's just code it out. So first of all, we will check if the list is valid or not. So if not had, then we will return none. Also, I will check if it is only if the list contains only one element. If not, head dot next, and the n value of n is equals to 1 or n is equals to greater than 1. So this is nothing but an extra checking. Ideally, we won't be getting a value of n which is greater than the number of nodes present, but it's just but since that's why I have written the or condition here. So either of the cases, if either of the cases true, then we can return none, because if I only have one element and I want to delete the second last or the last element of the list, then we don't have any like the list is empty. So that's what we are returning. So if we have a list with multiple nodes, then we will have 2-3 pointers. So first is the last pointer, so which is nothing but the first pointer that we are going to increment. So which will be pointing to head, and then we'll have the nth pointer, which will be first initially as none, and then we'll have the previous pointer, which will also be none at initially. So here the nth pointer is the nothing but the second pointer that we want to that we will increment one by one as soon as the last or the last pointer reaches or the traverses first n nodes, and then we will increment it like a sliding window thing. So as soon as the nth reaches the nth node, this nth pointer will reach the nth node at some point, and then we have the previous. So previous is nothing but, since we are working with linked list, so we have to save the address of the previous node in order to make a link to the next node. So this previous pointer will do that only. Then I will have k equals to 0, or sorry, k equals to 1, which is nothing but your count of the elements. So in order to make a window of n nodes, and then I have a flag which is 0. So this flag pointer will tell that at which point I want to start my second pointer, incrementing my second pointer from the first node or the head of the node, head of the list. So that's why we need f. So I will have I will traverse the list from the first node to the last node. So I will check if the last node exists or not. So as soon as my last reaches the end of the list, so this loop will break. So in the loop, I will check if the flag is equals to 1 or not. So if the flag is equal to 1, then if the flag is 1, so then I have to start incrementing my the second pointer. So since the flag is 1, so I will write previous equals to nth, and nth equals to nth dot next. So what I am doing is I am incrementing the second pointer, which is the nth pointer, towards 1 or the first element or the second node, and I am keeping the previous as the second pointer, which is just behind the end, like the second pointer. So I will move this something like this, and so in order to have the second last nodes or the previous node or value when I reach the nth node. So that's pretty much it. And again, next I will check if k is equals to n or not. So it's about triggering when I want to start that sliding window thing. So if I reach the nth node or first n nodes, I will start previous equals to head, and nth equals to head, and f equals to 1. So I have to start the triggering using for that I have to change the value of f. So f now becomes 0 to 1. So in order to start incrementing the second pointer, and that's it. And at the something that is comes very last. So in each iteration I will increment the value of the second or first pointer, which is last, to the next element each and every time, and I will increment the value of k for each iteration. So that's pretty much it. So how these things will work. So first of all, I will start with the first pointer. I will have both the pointers like last and nth pointing at the first node of the list. Then I will increment the value of last to the next node, next node, next node, and then whenever the value of k becomes n, so like I have traversed the first 10 nodes, then I will start incrementing the nth pointer from the first element to like the second element and so forth, so on and so forth. And at the same point of time, I will start incrementing the previous pointer as well, but the previous pointer will always be one node behind the end pointer. So now that I have like everything, I have the nodes available. Like I will reach the nth node and I will have the one pointer at the n-1th node. Now I will simply have to check if the nth node is equals to previous or not. So this condition is nothing but sometimes it happen that we have a list of 5 and we want to delete the fifth last element, so which is nothing but the first element of the list. So at that point the above loop will fail and we will have the value of nth and previous the same only. So in order to prevent that thing, so we whenever we have the same value of nth and previous pointers, I will do nothing. I will just increment the head pointer's value. So head pointer will nothing. So if I want to delete the first element, then it's simple. I just have to increment the value of head to the second element. So that's what I am doing. And if that is not the case, then I will just create a new link from previous. So I will just use previous.next equals to nth.next. So I'm making that link from the previous element of the nth value to the next element of the nth value. So that's what I'm doing, and as soon as the link is made, I will just return the head pointer. So let's run this code. So yes, this code is working fine. Let's say I change this value to 4, not 4, let's say 4 only. So yes, this code is working fine. Let's check for another boundary case. Let's say 5. So yes, this code is working fine. Let's submit this code. So yes, this code is working fine. We are getting 62%, so that's good. I think last time I did, it was giving me a result of 92%. So yes, this code will work fine. So it's better than the one pass solution. So you can always try this code. And thank you for watching. Thank you for your time. And please like, share, and subscribe this channel if you haven't subscribed this. Until then, this is Raj signing out.